You're here because you want to master atomic structure with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. So for atomic structure, it is very important to understand first the structure of the atom. Here, we have a diagram that actually represents the structure of the atom. You can see over here that it mainly comprises of a nucleus, which has protons and neutrons. This is found in the center. And you can see these rings that are around the nucleus, right? This is actually the electron shells, which houses electrons that are part of the atom itself. Each shell has a corresponding number of electrons. And what ties this whole structure together is this thing called electrostatic forces of attraction, or in short, EFOA. Now these electrostatic forces of attraction are between the protons and the electrons, mainly because, right, the protons are known to be positively charged and electrons are negatively charged. And because of that, you can imagine there's some sort of like the equivalent of a magnetic force between the plus charge and the minus charge. But instead of magnetic force, it's called electrostatic forces of attraction. And because of this attraction, the shells are kind of around the nucleus, okay, and they won't just like fly everywhere. So we must also know about the relative mass and relative charge of these different components of an atom. For example, a proton actually has a relative mass of 1, alright, and a relative charge of +1. Neutrons, on the other hand, have a relative mass of 1, but they have a relative charge of 0. Then we have electrons. They have a relative mass of 1 out of 1840, and they have a relative charge of -1. Next, let's talk about how do we interpret elements in a periodic table and how do we tell the number of protons, neutrons, and electrons in a certain atom, ion, or perhaps even an isotope. Generally, for an element, right, we tend to have two numbers. One is the proton number. This is also called the atomic number in some cases. And we also have the nucleon number, or we also call this sometimes the mass number. The number that is lower in numeric value is generally the proton number, and the number that is higher in numeric value is generally the nucleon number. Next, how do we calculate the numbers of each of the components of an atom? Well, you can start with the number of neutrons. The number of neutrons can be calculated by taking the nucleon number and subtracting the proton number from it. And this is how you find the number of neutrons. The number of protons is just the proton number, as dictated by the name itself. The number of electrons for an atom of the element, right, is equals to the proton number. Because in general, for an atom, the number of protons is equal to the number of electrons. The number of electrons for an ion can be determined by taking the proton number for the element and then adding or subtracting based on the charge itself. Generally, for a plus charge, right, this means that it lost electrons. And for a minus charge, this means it gained electrons. So let's take an example. For example, if it has a 2 minus charge, then we know that it actually gained 2 electrons. So we would plus 2 to the proton number if the element indeed had a 2 minus charge. Now here comes an important definition that you have to memorize. What is an isotope? Isotopes are atoms of the same element with the same number of protons but different number of neutrons. So let's take a look at this example over here. Chlorine is a very typical example. You can have 35 chlorine or you can have 37 chlorine. What's mainly different about these two is not the proton number, because they have the same number of protons. Instead, it is the nucleon number, because they have different numbers of neutrons. Now, what is so fascinating about these isotopes? These isotopes tend to have similar chemical properties as the atom, right? Because they have the same number of electrons in the outermost electron shell. However, they tend to have different physical properties from the atom itself because they have a different relative mass due to the different number of neutrons, and our physical properties tend to be affected by the relative mass. For example, the rate of diffusion, as we have learned in kinetic particle theory, is affected by the mass. So we were already talking about ions previously, and we need to know that positive ions are just atoms that lost electrons. So for example, a sodium atom tends to have 11 electrons, but a sodium plus ion, okay, with a 1 plus charge, has lost 1 electron and actually has 10 electrons itself. Negative ions, right, are atoms that gain electrons. So for example, you have an O atom, right, that generally has 8 electrons, right, but when it has a 2 minus charge and becomes an ion, it gains 2 electrons, so it has 10 electrons. Now a burning question you might have is, why do atoms generally become ions? Well, it's very simple. Because atoms, right, they gain or lose electrons to become ions to mainly achieve this thing called a stable octet electronic configuration. And this is very important to understand. Some people call it a noble gas electronic configuration, which is the same thing. Now, why is this important? It's because when atoms or ions, right, they have 8 electrons in the outermost shell, they generally have very, very high stability. And this is so stable that it is almost always preferred to achieve this state itself. So atoms generally would try to become ions to achieve this stable octet configuration. And this is also linked to our chemical bonding chapter, right, where atoms actually do bonding to achieve this stable octet electronic configuration. And we will get to that in the next chapter. So the last part of atomic structure is knowing how to form the electronic configuration. To form this electronic configuration, the first step is we have to count the total number of electrons for the atom or the ion. And we already know how to calculate this based on what I've run through previously. Step 2, you want to fill each electron shell, okay, to the maximum number of electrons. And the filling of electron shells goes in order. You want to fill it from the first electron shell to the second, then to the third, then to the fourth, etc, etc. Generally, you need to fill the electron shell all the way to the maximum number first. So for the first electron shell, the maximum number is actually 2 electrons, followed by the second shell and the third shell, which each have maximum 8 electrons, and the fourth shell will have a maximum of 18 electrons, and that's as far as you will need to know. So for example, sodium, right, it has 11 electrons. So what you want to fill up first is the first shell, which has a maximum of 2. So you take 2 off first, and then you want to fill the second shell, which has a maximum of 8. Okay, you still have 8 electrons, so you can fill it up, and altogether you have 10 electrons now. Then you move on to the third shell. So what you've used up is 10 electrons so far, and you know that sodium has a total of 11 electrons, right? So with that, you only have 1 electron left, so that will go into the third shell. So this would be an electronic configuration of 2.8.1, or you can put commas in between the numbers, that works as well, right? So the significance of this 1 is that this atom actually has 1 electron in the outermost shell. And a cool thing to know is that from this electronic configuration, you can actually kind of tell which group that the atom is in. So since it has only 1 electron in its outermost shell, we know that this atom is actually in group 1. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.